Hi, everybody. Welcome to WarKat, a show about artificial intelligence and the human intelligence behind it. I'm Neil Katz, a 20-year tech entrepreneur. With me is my co-pilot in life and in this show, Daniel Warfield, a data scientist, a writer, and educator around all the things you can do with generative AI as a builder. We have got a lot to talk about today, Daniel. This was
Yeah.
an action-packed week. It is May 15th today that we're recording this. 2 days ago, OpenAI had their spring release, which we did a pod about. A lot of new product came out. 2 days later, literally one day later, Google comes out with their retort, which I felt was, well, first of all, it took forever. It was a really long press conference. But they, from my opinion, I think you might disagree, they had so much product to release. And we're going to go through it step by step. You're going to take me through the things that you thought were most exciting from a technology perspective. I thought for me, the big smart thing Google did was they just integrated AI into everything across the Google suite. And that instantly puts this technology in the hands of 2 billion users. That's something OpenAI has to catch up to, and maybe they're going to do that with Microsoft. Obviously, as their partner, they have that possibility. But I saw almost generative AI receding a little bit as the star, and suddenly we have features that do interesting things inside the Google suite. It felt maybe less for devs, at least this presentation, and more for the front end consumer. But I want to jump into it. What did that was my take, but there's so much tech was brought forward. And I know you had a couple of things that kind of blew you away from a highlight perspective. And what was your top line take? What kind of really did you love or not love in what Google had to say?
Yeah, like, I think it's interesting. People have been thinking that Google's behind in the AI sphere
Yeah.
and that, ChatGPT or like OpenAI and stuff are out ahead. And, to some extent, I think that makes sense. But let's not forget who wrote the Attention is All You Need paper. Let's not forget who wrote the Flamingo paper. Let's not forget who created the TPU and the reason Grok exists. It
Yeah.
all kind of goes back to Google. Google is like a powerhouse. And it seems like while everyone's been sort of making incremental steps and like, whatever interesting things here and there. And, it's funny. A couple days ago, I thought those were amazing things. Maybe it was hype, maybe it was just branding, maybe they just did an amazing job presenting, but it really seems like Google blew it out of the water. And I think you're
Yeah.
totally right. It's product. It's really product because, a lot of companies have been dropping a lot of money on AI. And if it's not a product, if it's not useful, if people aren't using it in their daily lives, then, where does that money come back? What's the point? Right. So I think you're right. I think the idea of generative AI, I think the idea of LLMs, I think the idea like all these data sciencey concepts are fading into the background, and AI is becoming a product and it's becoming integrated in, daily life probably. So, yeah, let's get into it. It was it was a lot.
Yeah, let's jump right in. So there's lots to talk about. Let's take the first thing that you wanted to highlight, which I think was like the core transformer technology and how we're maybe similar to what OpenAI was talking about yesterday, being truly multimodal.
Yeah. So OpenAI, they released GPT 4.0 and they coined a new word. I'd never seen it before called omnimodality.
Yeah,
That
I'll call the marketing
concept,
department.
yeah. The marketing department had fun, but that's an existing term, and it's the normal term is multimodality. What a modality is in data science is like you might have text, you might have images, you might have video. These all behave differently. They have different problems. They have different solutions from a data science perspective. So for a long time, you train a model for one modality or maybe two modalities if you're
Hmm.
crazy. But Gemini really has been pushing this idea of multimodality and being natively multimodal. So instead of having a model for this and a model of that, Gemini for a while, Google's been pushing this idea of native and true omnimodality, big multimodality. It can understand video, it can understand audio, it can understand text. And I want to give you an idea of like why that's important.
Okay.
So imagine you're training a model on text, and it says, the text says not one, not two, not three examples, something like that. And by understanding that text, the multimodal model starts understanding the concept of three, which is, kind of cool. It sees three all around and starts learning what three is. But if
Okay.
you have the same model and it sees images, and it sees an image of three ducks and an image of three cats and an image of three balloons,
Yeah.
it starts understanding the concept of three from a completely different perspective. And if you have the same model understanding three in text, in audio, in video, in images, like that's part of the reason probably humans are so intelligent, because we understand so many things from so many different ways. And a lot of researchers think that true big multimodality is the key to the next generation of AI. So this
Yeah.
idea of Gemini being multimodal, it's a big deal from like a variety of reasons.
Yeah. My takeaway from it is, when these models have already basically consumed a large percentage of all the text on the internet. And, there's conversations about, there's quickly going to be more synthetic text than human text. And then you're kind of in this recursive loop of what are you training this thing on? Basically its own exhaust pipe. But if you widen that aperture and you think about all the visual data in the world and all the auditory data in the world and all the cameras in the world that have live feeds everywhere, that's a huge, I don't know how many orders of magnitude bigger, but many data set that these AIs can train on become much more interesting kind of software, creations. So let's jump into the next piece of the Google presentation that you thought was really interesting. And actually, this was also a contrast with what happened with OpenAI. Why don't you tell us about this?
Yeah. So OpenAI, in their recent announcement, they showed off this uh, like Windows/Mac OS application, right? So you can have like a
Yeah.
little chat GPT, on your screen. And the idea of GPT-4o is that it's omnimodal. It can understand, um,
Omnimodal.
yeah, the big O. It can understand like a lot, right? It can understand images, it can understand text,
Right.
But like there's a difference between having it as an input that's possible and
Yeah.
how good it is at that input, right? Those are two very different things. If you can understand images, but it only understands vague stuff, then
Simple things like, drawing a triangle and it shows you a triangle,
yeah, it's
something.
like that's a triangle. It's like that's cool tech demo, but it's 2024. You know what I mean? Like we're trying to get these things to actually be useful, not just like wow, it can understand what a triangle is.
Yeah.
And I think it's really telling. In the OpenAI demo, they had a code example and they copied the code, they copied the text, and they put it in the little window for ChatGPT. So they literally gave it the text information. They had the option to show it the screen, but they chose not to. They chose to copy the text over. In the Google announcement, they did a very similar example, but they showed a video of someone's phone capturing a screen with code and
Mhm.
then asked Gemini, what does this code do? And it gave a pretty good answer. And like, again, the devil's in the details, right? If you want this to actually be useful in people's daily lives, if you want to make blind people be able to see, if you want to ingest large amounts of image data and process it to a high degree of fidelity, you
Mhm.
need the capacity to understand things like text in images. This is a hard problem. It's
Yeah.
kind of hard to describe in, a couple of minutes, but understanding this dense text in an image format is pretty difficult. And the fact that Gemini seems like it can do it so deftly, I think is a really big deal.
Yeah. So this was like a two-part trick, basically. Trick's the wrong word. This is a two-part capability. First, we can understand all the text that's in the image. Then we understand that it's code, and then we can actually start to decode the code and actually help an engineer write software. So I agree with you. It's a pretty smooth presentation of how to integrate two different skill sets this model has.
And before you transfer, it was such a cute little demo. It was going around like with the video and like taking videos of stuff and doing different demos. You might see a pair of glasses next to an apple on the bottom right. After this demo,
Mhm.
the demoer was like, "Hey, do you remember where my glasses were?" And because it's ingesting video, It just happened to have seen that the glasses were next to an apple on a desk, and it told the person, right? So it's like, the idea of multimodality from a theory perspective, it's like, it's kind of vague, but when you have a model that can understand everything, or at least that's the idea, the doors open to a tremendous degree.
250,000 years of human evolution, billions and billions of dollars of investment spent on AI, and finally, our species can figure out where my keys, where are my car keys? We've done it. This is the pinnacle. So this is kind of another example. Why don't you just give me 2 seconds on this, because I want to jump to the next thing, but I did think it was worth mentioning the sophistication of this diagram. And it's kind of, to your point, taking the visual recognition to a level that's much more useful, because you can really get to much more practical drawings that an engineer might be able to use, or everyday people.
Yeah, during the demo, you can tell who the engineers were. Like, there was like not a lot of people cheered, but the people who did cheer, they cheered really loudly. Like, these types of diagrams, when you're dealing with complicated systems, they happen all the time. Like, this is how humans talk with humans about things that they're actually dealing with and care about. And the fact that they could point a little arrow at that spot and then say, hey, how do we make the system better? It recommended caching. It's kind of a basic thing, but the fact that it understood the context, it understood the diagram, and then could give such a contextually aware answer,
Right.
really, really impressive.
Agree. So the next thing up, Google's been really pushing the limits of token window. And for those who are listening who don't know, a token window is essentially it's the bandwidth of how much information you can transmit or communicate back and forth with these language models at one time. And the world's been dealing with pretty small token windows since the birth of large language models. The ability to send a page or two of content at once. And in Google's last release, they said, hey, now we can do 1 million tokens. I think that's roughly maybe 1,500, 2,000 pages of text.
If I recall correctly,
2 million tokens.
If I recall correctly, it was 21 Cheesecake Factory menus is what they said in the demonstration.
So fair enough. So I think this is a pretty big deal for the business community. I think it's a less big deal for the consumer community, but I think it's a big deal for the business community, where you're trying to build applications with large language models, often RAG applications, or retrieval augmented generation, which is essentially a kind of application where you use the large language model as the brains of the application, and your private data is stored sort of in a different server, and that's the memory of the application. You bring those two things together, and it's kind of magical. It lets you use the power of these language models on the private data inside your company. And so when I hear large token windows, some people have said, well, that's the end of retrieval augmented generation. It's the end of RAG. You don't need this system in the middle if you can just load up all your content natively into the language models. I felt this is still not even close to that. 21 Cheesecake Factory menus is pretty cool. It's cute. It is nowhere near the level of the size of data problem you have if you're a hospital or a pharmacy or a bank, or even just a local lawyer who might have 100,000 pages of text and images and content in a single personal injury case. And if you're a law firm, you certainly have tens of millions of pages to be dealt with. So I don't know what your take is, but I felt like this is cool. It's good. We need these larger token windows to make these applications run better. But for folks who are saying RAG is in the bag, or RAG is finished because of a 2 million token window, I don't think it's even close yet.
I think you're right. I think in like trivial applications, maybe, right? If you're using RAG and you don't really need to be using RAG, then maybe, like people's pet projects will maybe include RAG a little less.
Right.
But I think you're right. Like in enterprise applications with large amounts of documents, I think you're on the money. I think.
Do you want to talk more about that? Let's jump to the agents. I think actually.
Yeah. We can go to the agents.
Let's jump to the agents, because I think this is where a lot of the maybe consumer excitement was, but I think there's a lot of engineering behind this that's also pretty exciting. And I know you do a lot of work around agentic engineering with large language models. So why don't you describe to us what this demo was? We only have a picture and a video here, and then how you think they're doing it and why you think this matters.
Yeah, I'm happy you're right that we need to switch because we got a lot to talk about with agents. So we're 15 minutes in, we're getting into the meat of it. The meat of
Yeah.
it. This was a big this is a big announcement. So for those who don't know, an agentic system, agents, they used a different word than agentic. I forgot exactly what they used, but an agent is essentially a code abstraction. So instead of like talking to a model directly, you loop a model into some code, and that code is designed to allow the model to talk with itself in terms of like thinking, so it can sort of plan and reason.
Right.
And it also interfaces the model with tools. So you can tell a language model, hey, if you output the word search and then some text, I'll search Google for that and I'll give you the answer. So you can tell a language model stuff like that. And you can make a bunch of tools and you can give it like some pretty complex reasoning abilities. And by wrapping LLMs, or I guess maybe language models isn't even the right word anymore because we're going so multimodal, by
Right.
wrapping large AI models in these abstractions, they can do some really powerful stuff. And OpenAI has been kind of leaning in that direction. A lot of the industry has been leaning in that direction slowly. Google just kicked that door down and barged in, and agents are here. Like it's a big deal. So they had a bunch of examples. I think guess we should just fly through it. So in this particular example, this woman was recording a video and was like, "Hey, my record player is broken. I don't know what's up." And instead, if you experience something like that, you got to look up the code for like what model record player is this. You got to figure out what the thingy is that's broken, and you need to like search, I don't know, the internet somehow, maybe ping Reddit and be like, hey, has anyone else had this
Yeah.
issue? And then some
There's a lot of
weird
work.
guy, yeah,
You're doing
some guy,
a lot of steps, a lot of work to
yeah.
even figure
So
out what record player you have, and then who knows anything about it. It's going to be in some nerdy forum somewhere. It's not going to be on the website of the company, probably. You've got some weird problem. It's anyone who's done this, which is kind of everyone knows, this is I don't know, 20-30 minutes down a internet rabbit hole.
absolutely. And you get distracted halfway through. Now your day's over.
For sure.
But so the idea of an agent, like what if you could ask a language model that could not only just answer straight up questions and stuff, but what if you could ask a language model that could understand your question, plan out those steps for you, then execute search on your behalf to aggregate all the information, then observe all that aggregated information, and then give you a response that's tailored to the video that you sent it. So it's like looking at the video, it
Yeah.
figures out the model number because it's multimodal, it plans out all these steps and it executes. And this is a cute little example, but like agents are gonna be everywhere. Maybe we can go to the next one.
Yeah, for sure.
So like, yeah, like you can use a better search, cool. But agents aren't restricted to just searching stuff. Google has access to a bunch of tools. They have access to Google Docs, Google Slides, Google Sheets, Google Meets. That
All your
there's a
stuff.
bunch. What's up?
They have all your data, and I think this is, for me, there was like a new level of discomfort actually, um, and I need to get my head around it. And in fact, it's why I've turned off Google. I've turned off these features inside our own G Suite inside our company. We have security guarantees, security arrangements with our clients to keep their data private. And it's like, wait a second, Google's AIs are now scanning the contents of the files that I'm storing on G Suite. And if any of those are my clients' files, that means that Google is now dipping their AI into files where no one's asked them to dip their claws. Now, I think it's super useful for in a lot of ways. You're going to tell us about that in a second, but I think people also need to be a little bit, just know what's going on here. That Google is ingesting all of your data essentially, and whether they're training on it or not, I think is a bit vague. I didn't hear anyone talking about that, but they're certainly consuming it and then doing something with it. The thing they're doing with it's super interesting though. So why don't you tell us about that?
Yeah. So we mentioned this idea of like you have a video and you're like, hey, can you fix this? But you also have Gmail, and your Gmail might have a bunch of receipts, and you might be trying to like figure out a budget. So you can ask Gemini, hey, can you comb my email? Find my expenses. Well, you don't have to say all this. You say, hey, can you help me figure out an expense report? And then it plans out a process. It's like, okay, cool. I can check out your email. I can comb through it. I can get expenses. I can populate a Google sheet, and I'll give you an expense report. Also, do you want me to keep an eye on your Gmail so I can keep this sheet populated over time? So you have this like little, now suddenly you have like a little assistant that's just watching your email and populating this expense report. It's wild. Like the sky is the limit with this technology, and we're just getting into it. Also,
Yeah.
by the way, I wanted to mention they did claim that they're not training on your data. They did claim that they're only using it, for processing like any other software, I guess, in theory.
Right.
But it is some kind of hocus pocus new stuff. Like, what can it is one of the tools to delete my sheet? What if it hallucinates? Can it just delete my sheets arbitrarily? Like,
Good question, right?
yeah, I think you're right. I think it's definitely very exciting, but it is a little spooky.
It is a little spooky. Maybe in the same way that everyone got their heads around the fact that Facebook's pixels are tracking you, and that freaked everyone out for a while, and there's much debate, and then everyone just sort of forgot about it. And, oh, I guess they're tracking me, and I get weird ads following me around the internet, and maybe this is a version of that. But I think something they didn't really talk about in all of this presentation, in my opinion, is I think the elephant in the room is hallucination. You just mentioned it. They're doing a lot of, okay, it's an amazing demo. Everything they did was very cool, but we know demos are demos, and that's not necessarily real life. How much hallucination is happening when Google's now ingesting your real documents, which come in all kinds of flavors. Now you've got spreadsheets, you might have PDFs, you might have receipts that are in PDF format, you've got visually complicated things. We know certainly from our work at eye level that that's a place that often trips these models up. And we do a lot of work to fix that. But what's actually happening under the hood here? How much hallucination is occurring that they're not talking about across the entire suite of applications? And it's really relevant because when Google releases something and it kind of like lives in the background, I think everyone just pretty much assumes it works. It's like if Google says, yeah, it's going to find all the receipts, and it's like magic, and it doesn't find 30 receipts, you just kind of assume it's right. And I'd love to hear a lot more from them about what their accuracy is like across just the complicated universe of real world data and documents that actually trips language models up. If you're in the business of building these softwares, that's actually one of their big weak points. I wonder what your thoughts are from that, from like an engineering perspective.
I think you're totally right. I think, if anyone's up to the challenge, it's Google. Right? They're kind of like the it team. DeepMind is kind of wild, and I'm sure they have a lot of amazing technology around that I'm not privy to.
Mm-hmm.
But I agree, like hallucination is a big deal, and these language models aren't intelligent. I have a whole article about how they're basically just filters. They're giant filters, and
Yeah.
you can wrap them in this like sort of agentic system, and you can build tools to make them more robust. But that at the end of the day, you need some really good guardrails that are really well designed to keep things constrained. So I think their strategy for that right now is to roll Gemini out in kind of non-critical applications and in specific use cases, and
Yeah.
use those as test beds so that they can incrementally grow. Um, but
But your
yeah,
personal finances is not that non-critical. I mean, fixing the record player, maybe it fixes it, maybe it doesn't. It's going to be pretty obvious to you very quickly if the thing it tells you to do works or doesn't work. But if you're saying, hey, organize my finances, it's like it's not just that it hallucinates potentially by making mistakes. There's the potential of error by omission. How many receipts did it not figure out that they were receipts? that's in addition to it potentially just making up data about those things. And that might be mission critical to your life, right? You're doing your taxes. That if you're relying on this software for that, that's not so incidental to you. Maybe to Google. Maybe you're not a bank, but you're not a regulated entity. But it's still a big deal for you.
Yeah, I think the idea of accuracy and what is good enough is interesting because humans make mistakes too, you know? So it's like, it's a really tough question to answer. I think there's a famous paper somewhere. I can't remember exactly which one, but they're basically like, we have several metrics for evaluating if our LLM is, performant or not. But we've concluded that the only way to truly know is to vibe with it. You have to talk with it. So it's these things are tough to, yeah, they're tough to evaluate. They're tough to prove in every use case. And Google does have pretty robust systems for testing these models and finding out if they're performing or not, but it's an uphill battle for sure.
We're gonna see as this plays out. Should be interesting. All right, so the next one, you thought this might have been the showstopper, I think, of the whole Google presentation, and this is an example of like a three-way. We're now, look, it seems amazing to me. It was just 18 months ago that having a two-way conversation with a computer was literally science fiction, mind-blowing experience. You're talking to an alien. Everyone couldn't believe it. This was a demonstration of a three-way conversation, two of them being AI, one of them being human. Not easy to pull off, very, very lifelike. Really might have been the thing that felt most like sci-fi. So why don't you dig into what was presented here and what do we think might be the engineering behind it? Because I think it's not actually totally clear how they did it. We have some theories about different approaches they could have taken.
Yeah. So, the background of this is OpenAI. They had a very, high quality voice synthesis system, and it had some hiccups. It had some problems, but OpenAI the day before released something where you could communicate with ChatGPT in a way where it could like articulate, you could get it to talk in an excited way, in a confused way, in a robot voice, whatever. Very human interaction. And that was pretty impressive.
It was.
And yeah. And then Google just kicked that door down too. And they were like, you think it's cool to have a conversation with one person?
Hold my beer.
Yeah.
AI.
Yeah. So there was basically the use case was like this kid was like learning about, I don't know, geometry or physics or something. And the parent was like, hey, can you teach my student like this topic? Can you teach my student this thing? And I can't remember if they uploaded a transcript or whatever, but I can't remember if they asked for this sort of style or if the model decided to generate the style. I'm not sure. But basically, the model didn't just talk to the student. The model, it seemed like, generated two voices, like two distinct characters, and had them talk to each other podcast style in order to like teach this class. So it was like, hey, like this, right? Hey, what are we learning about today? Oh yeah, we're learning about something really interesting. So there was this back and forth between these two voices, and then the kid could chime in and be like, hey, I'm confused about this. And then both those voices could talk to the kid. So like it was like you could chime into a three-way conversation between these two people that are probably one model that's generating audio and doing all of this orchestration. Maybe it was wild. And it was, in my opinion, way more impressive than OpenAI's demo of a kind of similar technology.
Yeah, I mean, I'm immediately thinking video game, right? Where you have potentially thousands of characters that have different personalities and are able to interact. And if these models can be fast enough, these are this is like holodeck kind of experience. It's not VR, of course, not what they're doing, but this is, this is kind of a potentially next level experience. It was very, very, very interesting. I was very impressed by this component. All right, the last piece of the puzzle we want to talk about is something called SynthID. And I think you want to tell us technically what SynthID is. I think you were impressed by this. I actually had a maybe contrarian point of view on it, but why don't you get into it, and then we'll kind of debate whether this is the right way to approach tagging synthetic content.
Yeah. So I don't know if it's the right way, but I'm happy to see it. Like this is a big stage. OpenAI, they don't really talk about safety that much. It's been kind of a joke in the research community. Like they'll be like, essentially their concept of safety is it safe for companies to pay them money. It's not really is it safe for people. Look, as an AI researcher, this is big technology and it's going to change the world. And if you're not thinking about safety, you're irresponsible and you're kind of a bad person. Honestly, hot take, but it's a big deal. Yeah, like it's a big deal, man. Like we're changing, and like let's look at the internet right now. Like take a half step back. It's changed the world for the positive, but social media, you know, we've all read The Anxious Generation. We know how big of an impact it's had on people. I don't want to go through that again. You know what I mean? I want a better future. That's what we're all striving for. And I think safety is incredibly important. It's not the most exciting and flashy topic, but if you're not interested in safety, you're driving down a hole really fast. And I think SynthID, was it the most amazing technology? I'm not sure. Basically, the idea is you can put an invisible watermark that flags an image as AI generated. So imagine you have a fake image of a presidential candidate and you want to know, hey, is this AI generated or not? There's like this imperceptible, hopefully immutable filter that like allows it to be perfectly described as this is AI generated or not.
Right.
Is that the perfect approach? I'm not sure, but we need to be thinking about safety. I think that's the big takeaway. I need every single presentation by these large companies talking about safety. I need everyone bored. I don't care. It's a big deal.
So I agree with everything you said from an ethical perspective, from the greater good perspective, these technologies, and boy, 20 years post invention of the internet, if we've seen a rabbit hole of problems that few predicted at the outset. So I agree with you. I am very glad to see that Google's addressing this and trying to be more responsible with the technology. Just from maybe from a technology and maybe a tactical point of view, I think it's not the right approach necessarily. But look, Google can only do what Google does, right? They can only work on their technology. But I think if you think about malign actors, you know, if Google's image generator or voice generator or video generator has watermarks that are effective, well, then people are going to use open source technology that doesn't have those watermarks on them. So I actually think the right way to handle this is for maybe the camera companies to get together, or the chip company, you know, the Apples, the Googles, and the camera guys, to verify when real images are taken, to verify that those are authentic. That's the watermark I need, because there's far fewer real things in the world, at least soon to be, fewer real things than fake things. If I think about, you know, you take the Biden example, there aren't that many actual photographs or videos of Joe Biden on a daily basis. So the number of things you have to track that are real is like, I don't know, hundreds a day, maybe. Whereas with these models, you can make millions or billions of fake Joe Bidens a day. So tracking the universe of fake, to me, feels like a multiple orders of magnitude problem that's more complicated and bigger than tracking what's real. Now, to do that, though, it's like a conglomerate of different people, and Google's not really the player here. You know, you have to, Google's part of it because Android phones generate real images and real video. Apple phones generate real images and real video. Canon cameras generate real images and real video. There's not a billion companies that do this, right? There's probably dozens and maybe only a handful that account for most scale. So I actually think you got to get the source material right. And then people know if it doesn't have the watermark as a true original, well, buyer beware. Maybe it's true, maybe it's not, like a lot of things on the internet. But unless you see the real watermark, that this was truly the video taken on that day of that person, certified, you know, you don't know quite what you're getting.
Yeah, I think maybe blockchain will actually be useful.
Yeah, it's funny because I avoided using the word blockchain. I actually think this is a great use case for blockchain as a way to put, you know, as a platform to store the authenticated images and their provenance. It's not the only way you could do it. It's the decentralized way to do it. You could imagine a centralized version of it as well. You could imagine the Apple, Google, Canon consortium, you know, that's maintaining servers that hold these certificates. We trust them with all of our other data. I'm sorry, Microsoft might be in there too. I mean, exclude them. So it's not like we're not trusting these centralized organizations with most of our most important information in our lives, from our banking data to our photos of our kids. Decentralized would be super cool. I don't think it's required, but it would be a great use case of the blockchain.
Yeah.
Didn't expect to go crypto with this, but anyway, that was a lot. We covered a lot. Daniel, thank you so much once again for being on the WarKat with me. Great show, and we'll see you next time.